Okay, let's talk about calculus. And if you're watching this video, I assume you're interested in the subject of calculus. Maybe you're planning on taking a subject, or maybe you're just kind of just generally interested on the math called calculus. And calculus has kind of a reputation of being advanced and difficult, and in fact, it is. But the concepts and principles are actually pretty, understandable for anybody, and they're very beautiful. It's a calculus is such a powerful mathematics. So the whole point of this video is to kind of introduce you to some of the power of calculus. Okay, and we're going to be doing something here. It's going to be kind of a little basic, interesting problem. And if you've never done calculus before, stick around because this could definitely be your first calculus problem. And we'll kind of solve it together. But I will say, in full disclosure, that I am going to be doing some algebra, not much, okay, some basic algebra in this problem. So if you're not familiar with algebra, still stick around, okay, you'll learn something. But if you know some algebra, you'll kind of relate to some of the things I'm going to be talking about here in a second. But first, let me go ahead and quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. And over many years, I've constructed what I like to believe is one of the most robust, comprehensive online video-based math help programs there is. Now, of course, I'll let you be the judge of that if you want to check it out. But you can find a link to my math help program in the description of this video. But whether you need to take a full comprehensive math course, I can help you, or you need assistance in a course you might be taking right now, I can help you. All my courses have full comprehensive lessons, and I teach you how to solve the most common type of problems you're going to be facing at the middle, high school level, or even more advanced levels. Okay, I literally solve thousands of problems, and I think that's where my program is very unique. Okay, not many programs really have that much video content. But again, if you're interested, you can follow the link in the description below. Okay, now let's talk about math notes. If you are a math student, you may or may not be, but if you are a math student, you need to have outstanding math notes. Okay, after decades of teaching math, one thing is apparent to me: those students with the best math notes almost always have the best math grades, and the reverse is true. Okay, those students with no math notes, sloppy, disorganized math notes, and that was me way back in a day. I had to learn how to take math notes, and that's maybe your situation. Okay, so if your notes are not that great, don't get down on yourself too much. Just recognize that you have to start improving. Okay, but in the meantime, you need something to study from. So I actually offer very comprehensive, detailed math notes. You can find a link to those in the description of this video as well. Those would include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. Okay, so let's get into this problem. And you might be saying, well, what is this problem? Okay, well, here, let's just imagine we had like some ball getting fired up in the air, maybe a cannon or something, and this ball was traveling up and up and up and up and up. Okay, and then it kind of peaked, and now it's on the way back down. All right, so let's try to identify at what point does this ball reach its maximum altitude. Okay, that's kind of the general idea here. Again, it's not going to be an exact, this would be like an example of a physics problem. Okay, of course, physics uses calculus. All the sciences use calculus as the mathematics, the more, when you study them at a higher level. But we're going to basically find the maximum of a shape, all right? And I'm going to do that in just one second, but let's kind of emphasize why this is so unique. Now, if you've taken algebra, you might recognize this shape here as a parabola, okay? It's a parabolic shape, and we can just use some other algebraic techniques to find what we call the vertex, right? Which is this point up here, okay, which is the maximum. But I'm going to show you how we can use calculus to find this point as well, because this is a nice illustration, basic illustration of calculus. Now, in calculus, when you learn calculus, okay, uh, there's pretty much two big primary concepts that we learn, okay, big picture topics, let's just say. The first one is integration, okay. Integration is a little symbol like this. You've probably seen this before. Looks kind of crazy, like so. And let's suppose this was on an XY chart right here. Integration uh, is basically the way we can find area underneath a curve. with something, okay? So very, very powerful. I've done a few videos on the basics of calculus. So we learned integration, then we learned this other thing uh, called the derivative, okay? The derivative kind of looks like this symbol, dx, dy, or y prime. There's all kinds of ways you can, it's expressed, okay? But we learn about the derivative. So there's like the big, huge topic in calculus is the derivative, and then we also learn about integration, okay? In this particular problem, we're going to be using this concept here, the derivative, and the derivative, more or less, okay? Let's kind of erase all this stuff here. The derivative allows us to find the slope, okay? The derivative has to do conceptually with the slope of something. So here's my little curve, my little parabola, and along this parabola, let's say at this point right here, what's the slope of this parabola? Well, it would kind of be like this line like right here, right? That would be the slope. But what precisely is the slope of the parabola at this point? Well, that's where we need calculus, okay? But let's just kind of follow this parabola around and let's just study what the slope is looking like. How about this point right here? Well, at that point, the slope might be something like this, right? Okay, so we can see the slope is changing along this parabola. How about this point right here? Well, the slope is like, well, maybe like this. We kind of drew it kind of bad. Something like that. Now, this line, okay, is what we call a tangent line. This is one line that just touches at one single point that parabola at these precise points. So these lines are going to touch at that one point. Now here, this would not be the case, but I'm just kind of sketching around here trying to make a bigger point. Now, if you don't know basic algebra, when we talk about the slope, we're talking about the angle of something, right? The steepness of something here. So the slope in this direction, we indicate that by this little variable m, is going to be positive, okay? So slopes that run like this way, increase from left to right, is a positive slope. The slopes that go down this way is a negative slope. So what do you think a line that goes this way? What's the angle of this line? How steep is this line? Okay, this is a horizontal line. You might be saying, oh, it has no slope, it's zero. And you would be correct, okay? So lines that are flat, okay, or horizontal, okay, have zero slope. And I'm going to erase this here in a second. Okay, so these lines, horizontal lines, have zero slope, and vertical lines here, their slope is what we call undefined. We don't really need to get into that for this particular video, but just so you know, if I'm trying to find the maximum point, just think of it as a roller coaster. This is probably good representation. Here you are going up a roller coaster, you're increasing. Okay, so positive slope is like you're increasing on your roller coaster. And then right here at the very, very top, you're like flat, right? You're perfectly horizontal. You are like this. Okay, the slope is zero. And then you go down the other side. Roller coasters are so cool. Okay, and now we have negative slope. Okay, so this is where the slope is negative, this is where the slope is positive, and right here on the top, when everyone is just like scared, 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 and then you're like, oh, and you kind of go back down, this one point right there, okay, is the top, okay, of the roller coaster, the top or the maximum, okay, of this parabola. And that's what we're trying to determine. Now, again, if you studied algebra, there's other um, techniques, but this is a basic, simple parabola, okay? There could be more challenging techniques that algebra can't help us out, and we're going to have to use our friend calculus. Okay, so we're going to be using the derivative to determine the maximum of this parabola. So let's get into it now, okay? So here is our problem. Okay, we want to find the maximum. Now this particular function here, okay, its graph is not exactly this. I just kind of drew this to make it look kind of interesting. So here is this graph. Okay, this graph's really more like this on the XY plane. So here's our function. And if I was to graph this parabola, it would be like so. Okay. Again, I'm trying to find this maximum point right there. Now, that's also known as the vertex. We want to find this maximum point. Okay, where does this thing max out? Now, as I indicated, we're going to use this concept here called the derivative. And this is the notation. We want to find the first derivative of this function. Okay, so this is the notation again, dx dy. It looks like this. And again, you don't need to know a lot about it. Just know that we're going to find the first derivative. Okay, now this is the function. When I find the first derivative, dx dy, okay, or f prime, okay, this right here, this is actually the first derivative. I'm going to show you how I got to this. What does that mean? When I find the derivative, okay, this function right here, its graph is this parabola. Here is the parabola. This thing right here is the graph of that parabola. When I find the first derivative, okay, these are all equivalent notations. I could write it as dx dy, or I could write it like this. Now, notice I said the first derivative. I could find the second derivative. That means something in more advanced mathematics, especially like physics and stuff, but I don't want to digress too much because I could just get overly excited about calculus. It's such a cool topic. But anyways, here's the deal. When I find the first derivative of this function, here's the function, here's its graph. When I find the first derivative, it's going to give me a formula for the slope. Okay, so the first derivative is a formula for the slope of anywhere along this line. This is actually the first derivative. Okay, so I'm going to show you precisely what this means. So this is going to give me a formula for the slope, or m. Okay, now remember, we talked about our roller coaster. M is positive here. M is 0 right there. Okay, and then m is negative right there. So what I'm going to want to find is, where is the slope equal to 0? Okay, remember we just talked about that, because that is going to be the top of this parabola. Where the slope is 0 is going to be where the maximum, okay, point is on this parabola. All right, so how do we find the first derivative? Okay, so that's what it means. So here is how we find the first derivative. So in calculus, we're given a bunch of rules. They're not that difficult, just kind of algebraic manipulations. But here is our polynomial function, our little quadratic equation, if you've taken enough algebra to understand. So here's what we're going to do. Okay, to find the first derivative, we're going to take, this thing is written in highest power to lowest power. We take this little exponent right there. Okay, here let's kind of make it bigger. Negative x squared. Okay, so we're going to take the 2, we're going to multiply by that number. That's a negative 1. Okay, so it's going to be, we're going to take, you're going to be take the 2, we'll multiply by that negative number, which is this 1. Okay, so 2 times negative 1 is negative 2. All right, so take that little 2, whatever the exponent might be. If it was 3, I would multiply by 3. So take the 2, multiply by this number. That's negative 1x squared. So 2 times negative 1 is negative 2. Then I'm going to take that same variable x, I'm going to write it like so, okay? And then whatever this power is, it was 2, okay, or it is 2, I'm going to decrease it by 1. So that would be just to the first power, 1, okay? Let me do that again. All right, so we can understand this rule to have a function, a polynomial function, to be able to find the first derivative. It's not that difficult. So we have negative x squared, okay? Take the 2, multiply by this number, which is just a negative 1. 2 times negative 1 is negative 2. It's the variable x. Now, whatever this is, I'm going to drop it down by 1. So that's 2 to the first, or just 2. Okay, I could write it just like that. And that is step 1. Okay, now I'm going to do the same thing over here. All right, so what's the power of this? It's 1. Okay, so it's going to be 1 times negative 8 is what? Negative 8 times x2. This is 1. I'm going to drop it down by 1. So that's x to the 0. Anything to the 0 power is 1. Anything to the 0 power is 1. So that's really negative 8 times 1. So my first derivative is negative 2x minus 8, because it's negative 8 times 1. This is really just 1. And then when you're taking a derivative of a number, it's just 0, it goes away. Okay, so this here is our first derivative. Again, I'm using different notation. Here it's the function x, okay, f of x. So all equivalent notation, what we just found is the first derivative of this function f. So it can be written as dx dy, very, very common, okay? Or we could write this little apostrophe, that's the first derivative of the function f, or this function's name is f, I can write it like this, okay? All equivalent f prime, we would call this, okay? F prime, first derivative of this function. Again, this is a lovely formula for the slope, okay? It's going to tell me where the slope is at. Now I'm interested in where is the slope equal to 0, okay? Remember, okay? Just a quick review, the slope is positive in this direction. The slope is negative in this direction, but at this one precise point at the top of the roller coaster, the slope is 0. All right, so let's find that point now. Okay, erase all of this. Okay, so here is my formula for my slope. I know my slope along this function, along this parabola, is equal to negative 2x minus 8. So I want to say to myself, okay, Mr. Slope, where are you equal to 0? Because that's where I'm interested in knowing, okay, where the slope is equal to 0. So I'm going to set the slope, the formula, or the equation here for the slope equal to 0, and I'm going to solve that equation. So negative 2x minus 8 equals 0. I'm going to move the 8 over to the other side of the equation. That's negative 2x is equal to 8. And I'm going to divide both sides of the equation by negative 2. So x is equal to negative 4. Okay? So right here, 1, 2, 3, 4, negative 4, along where x is negative 4, at this point, that is the maximum along the x-axis of where that's at. And if I wanted to know this exact coordinate, I would just plug in negative 4 into my original function, and I actually just did that right here. Okay, let's plug in negative 4 into our original function to find out what the y coordinate is. And when I do that, whoops, you can see here, I'm plugging in very precisely negative 4 here. I do all the math, and f of negative 4 for this function is 7. So the top of that parabola, okay, right there, okay, is located at 1, 2, 3, 4, negative 4, 7. Okay, 7 this way. All right, not negative 7, but 7 in this direction right there. So that vertex, that maximum point for this parabola occurs at negative 7, 4. Now, uh, this is an illustration of using the first derivative, okay, of a function, all right, to solve a problem. Now, there is another way, more direct approach. We can use algebra, but this is an easy problem, okay? Algebra can, help us with the easy problem, but then there's a lot of other things that calculus just, cannot help us with, all right? But I, chose this because this is our first calculus problem together. I wanted this to make sense to you. And hopefully, even if you didn't get all the algebraic manipulations, I think hopefully you can understand the concept of the roller coaster stuff here and get an appreciation for the main basic concepts of calculus, integration, and the derivative. All right. Now, again, I'm oversimplifying a lot of things. And if you have, a pretty advanced math background, you might say, oh, you missed that, you missed this. Yes, listen, I get that, right? I'm not trying to teach a full calculus course here. That's just the point of this video. The point is to teach you a little something about the subject of calculus so you can appreciate it and maybe even get motivated enough, excited about it enough to be like, you know what, I want to learn this subject, okay? It's definitely a great goal. You might be like, yeah, well, you're a math teacher. You love math. Of course, you're going to want everyone to know calculus. I'm like, yeah, well, it is. People just don't realize, okay, without calculus, um, all our modern day technology would just fall apart. Right? Calculus has solved so many problems, technical problems. We just would not be here without calculus. We wouldn't have our cell phones. We wouldn't have airplanes, yada, yada, yada. Okay. Anyways, I don't want start preaching here about calculus, the importance of it. But it's just a fascinating mathematics subject, and it does take, it is a serious subject. You do have to really build up your math skill sets to be prepared to actually take it in a formal way. But I think that would be a noble goal for sure. Well, if you found this video entertaining, interesting in some way, or helpful, definitely appreciate you smashing that like button. That helped me out. And if you're new to my YouTube channel, hopefully you'll consider subscribing. I actually have hundreds and hundreds of math videos. Been on YouTube for a long time. Obviously, I love teaching math, so I have a lot of videos already organized in various playlists there to help you out. So you can just go to my channel, check things out. But I'm posting stuff all the time, all types of various level of mathematics. But if you want my best help, definitely follow the links in the description of this video. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.